Good everyone, my name is Graphics. If you look at the front of the screen, you will see a circuit that contains 10 resistors connected in either series or in parallel. You see I use the word in either series or in parallel because the circuit looks very complicated. You can see any two resistors that you can boldly say it is connected in what? In series or in parallel. Now, but I have a breakthrough here. How? Because whenever you have three resistors connected end to end, you see that resistor is in what? In delta. But when these resistors have a common point where they meet, you say that what? That resistor is in star. So this is telling me that this particular circuit, the resistors are connected in delta. And if they're connected in delta and they look this complicated, we need to transform them to star in order to expose them to know the one in series and the one in parallel, so that it will facilitate our what? Our process in getting the equivalent resistance. Because the question tells us that we should find what? The equivalent resistance of this circuit, and also we should find the total current. In our previous video, we have discovered and proved the formula in transforming a delta to what? To a star, which is what I have dropped at the top right corner of the screen. How to transform from what? From delta to star. Now we have delta 1 here, delta 2 here, delta 3, and also what? Delta 4. So either you take delta 1 and 2, or you take delta 2 and 4. Yeah, that is either you're going horizontally or you're going vertically. For this video, I'll be going horizontally. In the next video, I might still solve the same circuit going vertically. So you will discover that we have the same answer. So let us go horizontally. So I'm going to be considering delta 1 and what? And delta 3, which is saying, let me name this circuit in order to enhance our understanding. So let's say here is A, B, C, D, E, F, then here is G. So if you are considering delta 1 and 2, so I've brought them out in this manner. You can see that. So these are point B, C, D, G, and what? E. So we have the resistors there, 4, 2, 2, 2, 2, 4 ohms resistor respectively. Now, to bring the delta means that I must bring three resistors inside this delta that has a common point. Right? They have what? A common point. So if I place my common point here, so I'll bring one resistor connected to that point from point B, right? I'll call it R1. I'll bring the other resistor coming from point E to that point. I'll call it R3. And I'll bring another resistor coming from point G. Let me call it what? R2. Is that okay? Now I need to know R1, R2, and R3. I'll do it for both sides. So I can come here also, since it is a mirror image of each other. So what you get for the first one, you get for the second one. So let's move in order to make our work faster. Now, from the formula, recall R1 is given to be what? 4, that is the multiplication of the adjacent sides, that is the two resistor that is close to it, divided by the addition of everything involved in that delta, all the resistors involved in that are connected end to end. So you see that resistor 2, 4, and 2 are connected end to end. So you are going to add all of them. So the two resistors that's adjacent to that R1, multiplying both of them divided by the addition of all the resistors in common to that particular delta. And this is 4 times 2 divided by 4 plus 2 plus 2. So my R1 will now give me 8 over what? 8. So my R1 is 1. All together. So I'll simply just put 1 here. So similarly, the same thing to get my R2. Now R2 have 2 adjacent resistors, which is 2 and 2. So the same thing is applied, multiplying the 2 adjacent resistors all over addition of all the resistors that is what connected in that particular delta. And that is 4 plus 2 plus 2. So we're having 4 over 8, and that will give us 2, 1 and 0.5. That's my R2. I can easily come here and put 0.5. To get R3, right, it will be the multiplication of the product of the two adjacent resistors, which is 4 and 2, divided by the addition of all the resistors that are connected together. And that is 4, 2, 2. You add them, so we have 8 over 8, and that is 1. So we are done in getting R1, R2, and what? R3. The same thing too, whatever happens here. So the R1 here is the R1 here. The way I named it. The R2 here is the R2 here, and the R3 here is the R3 here, because they are the same, right? So I will put in my values just to save our time. You can follow the same process and you get the same answer. So after that, this is what I'll be having. I'll now remove the delta formation there. That I'll remove the resistor to the part BG, the part BE, and the part EG. I'll now be left with just what? Point B, E, and G. This is what I'm just having here. Right? So we move forward. The next one too, the same thing happened. So meeting at point G, we have point C, D, then back to G. So we remove the delta part of it, and we're left with the star part of it. Remove the outer shell, and we're left with the inner shell, which is the star part of it. So this is what we'll be having. You can see that from B to G to C to D and to point E. So what do you notice? Arrow 0.5, 0.5 here are in series. Since we are not considering the entire resistors like I've been telling you earlier before this video, we're going to use a subscript aside from equivalence. So using arrow sub A. So my arrow sub A will now be given as 0.5 plus 0.5, and my arrow sub A will be given as what? As 1 ohm. So I'm going to replace these two resistors here by one resistor, which is what? 1 ohm. So you add them together. So 0.5 plus 0.5 will give us what? 1. So this is all what we have here. Are we together? Now once you've done that, I can now take it and put back to my circuit. So placing in the circuit, this is what we have, right? But remember that we didn't consider the 4 ohm resistor, that is, we didn't consider BC and what? EC, the part there. So I'll put it back. So can you see that? So this is what we're having. Now, if I should redraw this circuit to make it more presentable, now it looks bent, and so remember, all these things you see here, they are all wires, and wires can be manipulated. You can bend wire in any way. So if I don't want it to be at an angle inclined the way all these resistors are inclined. It looks confusing. So let me now straighten the wire back. So if I move from part A to B straight, then this 1 ohm resistor, I'll make it straight, right? Then split again. We have here straight. So this is what we'll be having here. This is what we have, right? So at point C, I made it also straight. So you can bend it any way you want to bend it. So this resistor is, this circuit you see is the same thing as this. Look at it carefully. So I'll be using this particular circuit from now on. So let me replace this with this. Alright, so why am I doing this? If current start flowing from the 5 ohm, from the point A, right, through to point B is split into I2 and I3. I2 and I3 flows through the form resistor, continue flowing and reach this point C. There's nothing for it to split for, so it will now continue flowing through what? Through the 1 ohm resistor, making 4 and 1 to be in series. Are we together? Now you can now use arrow sub B to be equals to 4 plus 1 because they're in series, right? Similarly in both sides, including this 4 ohm and this 1 ohm, they are also in series because the same current is going to flow through the 1 ohm and the 4 ohm. Just imagine if that I3 splits again into I4 and I5, the I5 will continue flowing until it passes from the 1 ohm, then straight down toward the 4 ohms until it gets to point E. So 4 ohm here and 1 ohm is in series here. Also 4 ohm here and 1 ohm is in series. So I'm going to add both of them. So I can say for the other one, arrow C to be equals to also 1 plus 4, right? So 1 plus 4, both arrow B will be 5 ohm and also arrow C will also be what? 5 ohm. So I'm going to input that in my circuit and this is what I will be having. If you look at it closely, it still looks complicated, but there's a way out. We have 3 resistors that is connected end to end. That is the 5 ohm resistor, the 1 ohm resistor, and the other 1 ohm resistor are connected end to end. Even though they look rectangular, but they are connected also in what? In delta formation, because the enter you see 3 resistors connected end to end together, you can transform that resistor into what? Into a what? A delta formation. So let's do that. So from this point here, right, let me call that point Q, and we have this point B that is here. I'll put a point at this end here. So draw a line having resistor, that is a wire, connected to that point here. So we'll call the resistor R3. Draw another point, another one from here, another resistor connected to this point also. We'll call it R2. Then from this point, draw another resistor from here connected to this line here, this wire here, and that is R1. Now we'll now look for R1. So R1 will be, like I told you, the 2 resistors that are adjacent to each other. You multiply them divided by all the resistors that are what? That are connected end to end, and that is 5 plus 1 plus 1. So we're having 5 times 1 is 5, 5 over 7. So my R1 is what? 0.71. R2 also, if you look for R2, right, you have 2 adjacent resistor, which is what? 1 and 1. So you multiply the 2 adjacent resistor divided by all the resistors, the resistance of the resistor connected together. And that is what? 5 plus 1 plus 1. At the end of the day, my R2 will give me 1 over 7, which is given as what? 0.14. Is that taken? Now we'll go again. R3, you multiply the adjacent resistors, the resistance of the adjacent resistors, which is 5 and 1. So 5 times 1, all over 5 plus 1 plus 1. And that will give us 5 over 7. So my R3 is 0.71. So we've calculated for my R1, R2, R3, meaning that you remove the outer shell. So you do away with the 5 ohm, the 1 ohm, and the 1 ohm. So you'll be having a connection in this manner. Can you see that? You'll be having a connection in this manner. So this is my delta star, this is my delta formation. So I've transformed from that delta to what? To star formation here. So you can see that. So now what do you notice? If I redraw this again, it is bent. I don't want it to be bent, right? If I should redraw that again, I have this. Look at what we have here. So I straighten the wire. The 0.71 ohm resistor, I made it straight, but I still have a node there. So that node, the next one we have 0.14 resistor and 1, I made them straight. Then we have 0.75 also straight. Then we have the 5 ohm resistor here. So this is what we have. Now what do you notice? The 0.14 and 1 are in series because they're on the same current will be flowing through them. That again, if current flows from point A to B, then down to this node, is split to I2, I3. So that I2, I3, the I3 will continue, the I2 will continue flowing, right, through the 0.14 ohms and the 1 ohms, making them to be in series. Are we together? So we will now be having 1.14 together with the 0.71 and with what? So we move forward. Now if you look that closely, right, this is what we're having. Now you discover that the current that flows through the 0.75 will continue flowing and come through the 5 ohm resistor, making 0.75 and 5 ohm to be what? To be in series. So if they're in series, you add them. So making this to become 1. So we're having 0. We're having 5.75, we're having 1.14 and 0.75, 0.71. These are my points B, E, F, and A. Now, what do you notice? At this point here, this node here, let me call it node Q, there's a split. The current that will be flowing through here will not be the same current that will be flowing through here. That is, the current flowing through 1.14 will not be the same current flowing through 5.75 because of that split. So making 1.14 and 5.75 to be parallel to each other. So what will you do when you see two things in parallel? You multiply both of them. 1.14 times 5.75 all over 1.14 plus 5.75, and that will give us 6.56 all over 6.89. I'll be having 0.95. Now what do you notice? These two resistors in parallel has become 1. So we'll now arrange them in this manner. So 5 is now connected in series with 0.71, 0.95. So you add the three of them together. So my R equivalent will now give us what? 6.67 ohms. Alright, so when you do that, the next thing is calculate for the current. So we know V is equals to I arrow. So my I is equals to V over arrow. So my I will now give me V is 30, R equivalent is 6.67, and that is what? 4.5 ampere. So this is the current that flows in this particular circuit. So if you have found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.